This lesson is on exponential functions. We're going to talk about what an exponential function is, how to write a function from a table, and how to graph an exponential function as well. Okay? So first, let's take a look at what an exponential function is. An exponential function is written in the form of y equals a times b to the exponent of x. A, this number right here, cannot be 0. This b has to be greater than 0, and b also cannot equal 1. Exponential functions are non-linear functions. Okay? So let's look at the difference between linear and exponential functions. We've talked about linear functions before. We know this to be written in slope-intercept form. Okay, so let's see how this equation or function matches the table. Remember, we always first looked at the y-intercept. This is going to be where it crosses that y-axis. When x is 0, y is 9. All right, and then we looked at, to find the slope, the change in y over the change in x. Well, x went up here by 1, every time went up by 1. Y went up by 3 each time, just plus 3. We added 3. To get our slope, we did that change in y over the change in x. So then we had 3 over 1, which was 3. And that's how we got our slope. Now let's look at it in contrast to the exponential function. Okay? When x is 0, so when x, here's our exponent is x now, when it's 0, 3 to the 0 power is 1. So when we cover up our base with the exponent of x, we again have what y is equal to, or our y-intercept. Okay, so our y-intercept here is 9. Now let's figure out what happens each time in this. Okay, x is going up 1 each time. That remained the same. Okay, and then y, well, let's see, it looks like it goes up 2, but then it goes up 6, and then it keeps going. Actually, what's happening is we're multiplying by 3. 1 times 3 is 3, 3 times 3 is 9, 9 times 3 is 27, and so forth. This ended up going up exponentially. So however it increased, wherever it went up exponentially, that is where this base comes from. It was a times 3, okay, and that's where we put the 3 to whatever the x exponent was. So let's see, so 9 times 3 to the first power is just 3, so 9 times 3 is 27. Okay, so let's do 3, let's plug in the 2 to the x. 3 squared is 9, 9 times 9 is 81. Exponential function. All right, writing an exponential growth function. We're going to write a rule for this. Remember, the first thing that we're going to identify is where it crosses that y-axis, and it's going to be when x is 0, y is a positive 8. And then remember how we write our exponential functions. We have the y equals, now that intercept comes first, so it's 8 times, now we need to find the rule. What happens each time? What happens to y each time? We're not adding anything because this is exponential. We're actually multiplying by 2 every time. So we actually have 2 is going to be to that x exponent, whatever x may be. That's going to be the rule of our function. Let's make sure that it works. Okay, so we have 2, we'll plug in 2 for x. 2 squared is 4. 4 times 8 is 32. So that function works. Example 3, find the y-intercept. We have 125, so let's start our function. Y equals 125 times, well, now we have to find the rule. Every time we're going here, we're being multiplied by 5. So we're going to multiply that function, 5, and then we always have that exponent of x, whatever x may be. Okay? So we have, let's do this, 5 to the negative first power is actually 1/5. 1/5 times 125 is 25. Our function works. Example 3, we have our y-intercept. So start your function, y equals 1/9. It's okay that it's a fraction, okay, times, well, let's see what happens every time. This says 1/81, if you can't read that. Well, to get from, and sometimes in the lower section, if you're dealing with those negative numbers, these fractions get small, okay? But to get from 1/81 to 1/27 to 1/9 to 1/3, okay, if you can see how that pattern is working, each time this is getting bigger, it's being multiplied by 3. Okay, so we're going to multiply the function rule by 3 to whatever the x exponent may be. Okay, so let's look. So 3 to the second power is 9, and then 9 times 1/9 is 1. So it works. And lastly, example 4. Our intercept is going to be 2. So y is going to equal 2 times, again, find your rule. Sometimes the fractions are more difficult to identify. So if you'd like to work here and figure out what happens every time we're multiplying, by 3 again. So times 3 to the exponent of x, and check to make sure that it works. 3 to the first power is just 3, and then 3 times 2 is 6. So that works. And then finally, we're going to look at graphing exponential growth functions. Okay, so if we're given the function, remember 3 times 2 to the x power, whatever x may be, let's start with your intercept. If x is 0, cover that up at the end there, y is 3. And then what's happening every time here? We're saying we're going to multiply by 2. So let's multiply that y. Okay, so let's say if x is, let's fill in our domain. Let's start with, let's just go basic. Okay, I just selected those numbers as my x values to write the rule to figure out the rest of my y's. Okay, so 2 to the first power is 2. 2 times 3 is 6. Okay, 2 to the second power is 4. 4 times 3 is 12. Okay, -1. 2 to the negative first, you may need to write this over here. 2 to the negative first is really 1/2 times 3 is 3/2. Okay, and then this last one, 2 to the negative second power, actually looks like 1/4, or 1/2 squared, times the 3, which is 3/4. Okay, now let's graph it. Now that we have a table, we can graph it. Yes, it's a little bit more challenging with the fractions, but that's okay. So let's start at the intercept. 0, we're going up 1, 2, and 3. We're going to 1, 6. Our 2, 12 value is not going to fit on our graph. We're going to go then backwards. Let's go to -1 and 3/2, or 1 1/2. -1, there's 1 1/2. And then we're going to go to -2, and we're going up 3/4, so not quite 1. Doesn't have to be perfect as long as you know where these values go. And that is our function. Okay. That's your exponential function. Example 6. Okay. Here we don't have a y-intercept. Okay. So we're going to know that it's not going to be 0, because if it was 0 times this stuff, everything would be 0. So when there is no y-intercept, it's like it's 1 times 2 to the x power. Okay, because if it was 0, then the whole thing would zero out and there wouldn't be a line. Okay, it would just be a horizontal line. All right, so let's look. So when we have a 0 in the x, y is 1. Okay, now let's fill in -2, -1, 1 and 2 for our domain or our x values. And then let's fill the rest of this in. -2 as the exponent, so 2 to the -2nd, again, is 1/4. 1/4 times 1 is just 1/4. 2 to the -1st power is 1/2. 1/2 times 1 is just 1/2. 2 to the 1st power is 2. 2 times 1 is 2. And then 2 squared is 4. 4 times 1 is 4. And then you can graph this line. Start at that intercept, going to the right 1, up 2. We're going to the right 2, up 4. We're going to the left 1, up 1/2. And then we're going to the left 2 and up 1/4. Okay. And then draw your arrows to connect. All right, good. So for your left-hand page, what I'm going to give you is 4 problems that you're going to graph. You should have the graph paper that I gave you in class. So the first one that I want you to, the first equation or exponential function that I'd like you to graph is y equals 4 to the x power. Okay, then let's try y number 2. Let's try y equals 2 times 3 to the x power. Y equals 3 times 2 to the x power. And then let's try y equals -2 times 3 to the x power. Okay, those are your 4 questions I would like for you to graph on the papers that I give you. Remember that you need to write this on a clean sheet of paper, and then we will glue it into our notebook later. The code word for this lesson is safety pin. Safety pin is the key word. If you have questions, as always, feel free to email me.